This is project 3, video number 2, the one in which we coded up. We've got MATLAB fired up. I'll type edit to get the editor open. Function. I don't think we return anything, so I'll call it dummy. I'm telling the user that I'm not going to use that variable. Dummy equals, I'll call it plot xt. We're plotting position versus time, and you don't think it takes any arguments. End, tab over for readability, and then I'm going to take a look at a code outline. Said initialize all these things. So I got a bunch of things to initialize, including times. So I'm going to try T0 as well. T0 equals 0. T1 equals 5 seconds. T2 equals 10. T3 equals 15. And that's it. And then positions, 0 is minus 15, then 122.5. I think I'm going to put it up here to save a little space and maybe keep things looking a little bit neater. We'll see if I want to keep it there. X0 equals minus 15. X1 equals 122.5. X2 equals, so this is position at that time, that's why I wanted to put it right beside it. X2 equals 322.5. Let's see where that is. Yeah, 322.5 meters. Alright, and what else do we have to initialize? The velocities 15, 40, and 40. V0 equals 15 meters per second. V1 equals, so this might be new to you. You can't actually put more than one command on the same line. Just got to separate them by space there. At least I'll try it anyway. V1 equals 40 and then 40. 40 meters per second. V2 equals 40 meters per second. And V3 is actually equal to 0, but we don't need it. X3 I don't think I ever calculated. Again, don't need it. Would be a nice check though. And then A0 to 1 is 5. I'm going to put that in here. Let's see if another tab works. A0 to 1 equals 5 meters per second squared. And I think I like that. And then A1 to 2 equals 0. I probably left that out. And A2 to 3. When I was doing the pencil and paper, I probably didn't bother to put that in there, but I'll go ahead and use it. Is equal to, or put it in there more for documentation purposes, to make it self-documenting, so a person gets the idea. At time 0, which is 0 seconds, we got this position, this velocity. At time 1, we got, which is at 5 seconds, we got this position, this velocity. And from time 0 to time 1, we got this acceleration. Alright, all of it's unused. I don't need those messages, but let's see if there was anything else that needed to be initialized. Got the accelerations. Nope, we're good. So I want to make sure that works. I'll take some of the semicolons off. Now, I'm going to actually leave it just the way it is with no semicolons, and I'll just go T0, X0, V0, and make sure they've actually got those values. You just type the variable with no assignment statement or anything, it'll just display that variable to the screen when you run it. So that's just a temporary check. Let's save this as plot.xt, and then I want to try to run it. Plot.xt to see if those values actually got there. And line 4, column 22, it didn't like something. And 1, 2, 3, 4. Yeah, need semicolons there. You got to use something to tell us the end of the statement if you want to do it all in one line like I did for several of these statements. A comma works if you don't want to print it, or if if you do want to print it, you can use a comma instead of an end line. But I wanted semicolons in all of them, so let's try that again. I'll save it. Plot.xt, T0. 0 minus 15 and 15. Yep, that looks like it's working perfectly. Alright, so take out this junk and save it again. Control S, and then see what we got to do next. So on the code outline, initialize all that stuff, and then I'm setting up these time 0 to time 5 seconds. Yeah. I'm going to use that idea, but I'm going to call them a little bit different. I'm going to call this T12 for, no, T01 from time interval, from time 0 to time 1. So that's from 0 to 5 seconds. And so that'll be 0, 1, 1, 2. And 2, 3 from time 2, which is 10 seconds, to time 3, which is 15 seconds. And see if I can remember this part of it. Alright, so I choose to change the names. Go T01 equals linspace 0, comma, and this is really from time T0 to time T1, so it's 0 to 5 seconds. And I'm going to go with the 101 values that I said before. So that initializes that one. I think I'll just try copying that. Control C, Control V, Control V. So I want 1, 2, which is from 5 to 10. And then 2, 3, T2 to T3, which is from 10 to 15 seconds. Alrighty. Then evaluate equation 1. using my time 1 to time 0 to time 1 and stick that in x0 to 5 seconds. I'm going to call that x01. So x01 equals and I got to find equation 1. There it is. X is equal to x0 plus v0t plus 1/2 a0 to 1t squared. Equals x0 plus v0 times t0 to 1 plus, I call it 0.5 times a0 to 1 times t0 to 1 squared. Now the thing is, this is an array of a bunch of values, and I want this whole thing evaluated on a value by value, element by element basis. So I put the dot in there, which says to square it on an element by element basis, rather than to try to multiply the whole array together times the whole array using matrix multiplication. Now over here I could put a dot star if I wanted to, but I'm just multiplying it by a number, so that is an element by element operation anyway, so I don't think I have to do anything with that. Then x02, I'm doing evaluating. Equation 2, stored in there. I'm going to call that 1 to 2. 0 to 1 was this one, and then 1 to 2, time t1 to, which is 5 seconds, to t2, which is 10 seconds. Okay. Equation 2 is probably the same thing, except with the appropriate amount of elapsed time. So this is going to be x1 plus v1 times whatever the time is from t1 to 2, t1 to minus t1, plus probably nothing, plus 1/2 a1 to 2 times t1 to 2 squared, but that a1 to 2 is 0, so let's actually take a look at that equation 2. It's just x1 plus v1 times t minus t1. Alrighty. So that's done. I'll put a semicolon at the end. This is a value being subtracted from an array. That's done by default on an element by element basis, so I don't need a dot minus. And then I'm just multiplying it by a number, so I don't need a dot star. Okay. From t1 to oh, that's what that was, from t1 to 2. So from time t2 to t3, from 2 to 3, we got, let's say something very much like this. x2 plus v2 times t23 minus t2, and then plus 0.5 times a23 times t23 minus t2 dot squared. Again, squared on an element by element basis. And that's probably equation 3. Let's see where we were here. So evaluate equation 3, store it. That was T2 to T3, the 10 seconds to 15 seconds I decided to call it, and store it in X2, 3, where the 2 corresponds to 10 seconds and the 3 to 15 seconds. It's just an index. Alright, equation 3 is what I gotta look at then. And yeah, that's just what I typed in. Alright, then I think it's a matter of putting them all together. Let's see what I wrote when I was thinking about that. Evaluate equation 3, and then put them in T all. I'll just call that T and X. So my T all is going to be T, which I'm pretty sure I haven't used yet. So T equals, then just put all these together, T 0 to 1, comma, T 1 to 2, comma, T 2 to 3. And X equals, similarly, X 0 to 1, X 1 to 2, and X 2 to 3. And I don't want those things printed out, so I'll put semicolons. Plot T comma X. I want to make a graph of X versus T, say put them in the reverse order with a plot command. And that should actually do it. So let's see what happens if I save that and run it. See if we get any errors. Wow. Okay, this looks just like what I had as an answer for the test problem. Here's that straight segment. Here's curved up to 5 seconds, straight up to 10 seconds, and then curved down and coming in horizontally, just becoming horizontally at the very end, really. Although with just 303 points, it looks like it gets flat earlier than that, but that's the idea. And here it's already got a little bit of slope. There goes up to looks like about 420. What I got on the test as a check was 422.5 meters. So this looks beautiful. We gotta title it and title the axis, so we still got a lot of work to do, but as far as the code actually doing what it's supposed to do, we got that, so we'll save the finishing touches and the documentation for video number 3. This is a wrap for video number 2, project number 3.